All right, so welcome back, everybody. I'm recording now. Just before we get well, I shouldn't say before we get started. Um, uh, just a review of what we did last week. On Thursday, we talked about the definition of acids and bases, and this is actually really, really, really important. So if I could draw a wink face here. This is so important for your second test or final exam. You should know the definition of an acid and a base. And specifically, we are looking at a Bronsted-Lowry definition. So, this definition comes from the name of two scientists. You don't need to worry about their names or anything like that. But the definition comes from two scientists. Sorry, I just read the chat. I am recording, if you're wondering in the chat. So, Bronsted-Lowry, the two independent scientists, came up with this definition for an acid and a base. And this is probably the best first-year chemistry definition for an acid and a base that I can give you. Acids donate a proton. Now, I know it doesn't say that on the slide, but this is, oops, sorry, ignore my pen there. This is technically a proton. You can ignore my writing. Wow, that's bad. Hold on, let me try that again. There we go. So acids donate or give away a hydrogen plus ion, which what we would call in chemistry is a proton. Acids always have hydrogen in the formula. So you would see like hydrochloric acid. This is acetic acid. Hydrophosphoric acid would be this one. I'm trying to remember all my names of acids. So acids typically donate a H plus or a proton. And you would typically see in an acid a hydrogen molecule. All right, let me check the chat before I move on. I have a good question from Aman. So, okay, I'm going to answer this. Okay, so the question from Aman, and this is a really good question. I'm going to erase my slides here. This is a negative compound. So why is it an acid? So let's skip ahead a little bit. A base is a chemical that takes or attracts that hydrogen ion from the acid. So this is like, it's like this perfect relationship. You can think of the law of conservation of mass or the law of conservation of energy, but the idea is an acid needs a base. They're like the perfect partner. So if an acid donates a hydrogen, the base accepts or takes that hydrogen. That's what, acid and base chemistry is. So I'm getting to your question, Aman, but I'm going to go a little bit further. It says here, usually neutral or negatively charged compounds are bases. So hydroxide, ammonia, HPO2. And you can see that this chemical compound is both an acid or a base. So what's going on? Why is HPO4 to the power of 2 negative, so I think it's like hydrophosphoric acid, why is this an acid and a base? And the answer is, this is a chemical that is called amphoteric. And you don't really need to worry about this term for a test or anything, but some chemicals can act as acids or bases, which means some chemicals can accept a proton like a base or can donate a proton like an acid. A good example of an amphoteric substance is something you're all familiar with, I'm sure, is water. H2O. H2O or water is a good example of an amphoteric chemical, which can act as an acid or a base. Don't think too much about this. Don't worry about this. Really, all you need to know here is that an acid is a chemical that donates or gives away a hydrogen atom, and a base is a chemical that accepts that hydrogen atom. And yeah, so there's a question in the chat, or a comment in the chat, I should say, from Mohammed. Does that have any relation with equilibrium? Absolutely. I'm going to talk about equilibrium in a few minutes. Hopefully, we'll see if we get there. But yes, this is absolutely due to equilibrium. Water, or HPO42 minus, these chemicals here, they would be in equilibrium, meaning they could go left and accept a hydrogen or go right and donate a hydrogen. So yeah, I'm very happy you brought that up, because that's like an amazing observation. Okay, but before we get too deep into equilibrium and observations, I have a term, sorry, that you guys are going to need to know. Wink, wink. I think I need, well, that's a pretty good wink face, but I think I need to work on my winky faces. So, okay. I don't know how to say this to you easily. This is just something you're going to have to memorize. When an acid neutralizes a base, the hydrogen, what we would call the proton, moves. Okay, so that's fine. We know here on the left we have our acid and we have our base. Again, this is like this relationship that you can't avoid. It's yin and yang, it's acid and base. If you have one, you have the other. Cool. However, we have these certain names for the chemicals on the other side, and it comes from Latin, and I don't mean to throw too much Latin at you, but we would call the chemicals on the other side the conjugate. Conjugate in Latin means pair, so partner. So on the other side, and again, this is going to be a little bit confusing, but we will do a practice example here. On the other side, so over here, what I'm circling, since it was the acid, we call this the conjugate. Sorry, I'm trying to avoid my words below. The conjugate base. Let me try that again. Let me write that again. This chemical is the conjugate base. Now, isn't that interesting? The acid on the left turns into what we would call the conjugate base, the partner base. the base on the right, or on, sorry, I shouldn't have said that. The base on the left, so this base here that I'm circling becomes the conjugate or pair or partner acid. Isn't that weird? So the acid on the left in the chemical reaction turns into the conjugate base or the partner base. The conjugate base in the reaction turns into the conjugate acid. And this is all part of the equilibrium. On the left, we have an acid and a base. On the right, we have an acid and a base. Again, very important that, and I'm going to show you an example in a minute. The acid on the left, on the right, turns into what's called its conjugate base. And the base on the left turns into, on the right, what we would call the conjugate acid. Very confusing, but I will show you an example. And I didn't mean to show the answer there. Okay, I have a million messages in the chat, so let me check that. So I'm reading the chat. Thank you, Harold. I'm trying to be artistic. And Iman, yeah, that is my logo. So, okay, so let's look, let me do an example for you. And then I'm going to get you guys to try 2 examples. And this is a good wink, wink. This is a good multiple choice question. If this was a multiple choice question, I would ask you, which chemical is A, B, C, D, which chemical is the conjugate acid, or which chemical is the conjugate base? So A, B, C, D, you kind of get the idea here. Okay, so how do I do this? How would I know? So split the reaction in half and look at the left side first. I know that HF it has to be the acid in this equation. Look at these 2 chemicals, right? I have HF and S2 minus. This has a hydrogen. This has to be the acid, which means this chemical has to be the base. Again, I hope you I really hope you understand that an acid is a chemical that donates or gives a hydrogen atom. This has to be the acid. HF is the only chemical here on the left. I'm only looking at the left. It's the only chemical that has a hydrogen. So this is my acid, which means by default, if the left chemical HF is the acid, S2 minus must be the base. If you have an acid, you have a base. I mean, it's like I said earlier, it's like yin and yang. It's like French fries and ketchup. If you have one, you have the other. Okay, so the question I'm asking you is on the other side, which is the conjugate acid and which is the conjugate base? Interesting question. And this is actually, I'm kind of upset about how this is laid out, but HF loses its proton to the base. So that arrow, guys, that arrow that I just drew is very, very important. I'm not saying you guys need to draw the arrow, but the concept of that arrow is very important. So that HF has lost its proton. So what we would call the F, I'm circling it and I'm erasing it, but this F over here, this is what we would call the conjugate base. The acid on the left turns into the conjugate base. The base on the right turns into the conjugate. I'm just going to say CONG acid. And you can tell it's an acid because it has a hydrogen. All right, and this is kind of like, I don't mean to go slow here or to, kind of make this, I don't know what I'm saying, but like, I don't mean to go too slow. It's so important that you understand how the equilibrium works. The acid and the base react. And on the other side, the acid becomes the conjugate base and the base becomes the conjugate acid. And this is kind of like our equilibrium reaction. So let me check the chat. I got a private message here. Sorry, I have a message from Abdullahim and a private message. So let me read those. So Abdullahim, yes, the acid always turns into the conjugate base, and the base always turns into the conjugate acid, always. And again, I don't mean to confuse you with the term conjugate. Conjugate is just a chemistry term for pair. So the acid is paired with a base on the other side. The base is paired with an acid on the other side. And now I have multiple private questions, which you guys can't see. So let me read them to you. So one private message says, generally, original acid turns into conjugate base and original base turns into the conjugate acid. Yes. So to you who wrote me privately, I won't say your name, but yes, you have that perfect. In the second private message I have, it asks, sir, how can we determine which is the conjugate acid and which is the conjugate base? And that's initially the question that I'm asking you. I want you guys to try this. Okay, so here's my compromise. Let me do one more for you. I will do question B. I have the hiccups. I don't know why. And then, so after I do question B, I will show you question C. So for the student who just asks, how do you know which is the conjugate acid or which is the conjugate base? Watch me do question B. Now I'm going to erase my text here just so this question looks simple. I don't want a lot of confusing letters or numbers, and I'm going to pick purple. Okay, so I'm doing question B. Watch carefully, because honestly, guys, question B is about as hard as you would see this question. I have, oops, ignore that. I have on the left HSO4. Okay, with a minus charge. And I also have an H2CO3. So what I need to do is monitor or look after the hydrogen. Which hydrogen is moving? Which hydrogen is transferring? So I'm going to look over here. I'm going to look on my product side. On my products, I have H2SO4. Now that's interesting. I went from on my left HSO4 to on my right H2SO4. So what that means is this chemical H2CO3 has to be the acid. And I know that because on the product side, I see H2SO4. I know that this chemical, HSO4, gains a proton. Okay, so my left side is done. I know which chemical is my acid, and I know which chemical is my base because I looked at the products. Now, the second part of this question is, which is the conjugate acid and which is the conjugate base? Well, let me pick a different color. I'm feeling orange. The base chemical always turns into the conjugate acid, and the acid chemical always turns into the conjugate base. It's an opposite system. So the acid and the base on the reactant side become opposite on the product side. And we use the word conjugate to explain the difference between them. Okay, let me check the chat. Yeah, I mean, again, Mohammed, I think you've said this, or well, I have a few Mohammeds messaging me, but Mohammed Abu mentions this perfectly. Acid and base become conjugate base and conjugate acid. Oh man, I'm getting a lot of questions. Okay, hold on one second. Let me read these questions. Mohammed Abu, you mentioned standard form. I don't really know what you mean there. We write chemicals just like I have written on this slide. I'm not sure what you mean by standard form. I have a private message from a student. Bases. So the question is, sir, are bases negative or neutral? Yes. Bases are typically negative chemicals or neutral. And I almost said your name. I guess it doesn't really matter. But I have another question. Do bases give protons? No, 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 no. I cannot express that enough. Acids give protons. Bases accept or take protons. And that is literally, if I could teach you one thing today, acids give protons, bases accept the protons. So with all that said, and me commenting on all of your chat questions, I would love for you guys, whoops, ignore that, to try this question, question C. I'll give you 1 minute. I want you to label these chemicals. I want you to label the acid, the base, the conjugate acid, and the conjugate base. And again, conjugate means partner. I will give you 1 minute to do this, and I will be right back. Here we go. So a lot of beautiful comments in the chat, a lot of questions about bases being negative or acids being negative, and I hope C, whoops, let's pretend that didn't exist, will explain that. To do a question like C, you need to split the reaction in half. We have the reactants on the left, products on the right. And what we're like, honestly, what we're trying to do is follow the hydrogen. Where did the hydrogen go? Which chemical on the left? All right, so look at these two chemicals. Which of them donated a proton? The only way to honor the Okay, so Mohammed circled the answer there. The only way to know this is to look at the products. Look at my products. So I have H2PO4, HBO3. On the product side, I have H2, very important that you notice that, BO3, and HPO4. This chemical, again, this HPO4, this phosphorus chemical, has clearly lost a proton. So that means, by definition, this is my acid, and this is my base. Again, the acid is the chemical that gives a proton away. The base is the chemical that accepts that proton. And I can tell that because of the reaction. So the next part of this question, wink, 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 wink. Which is the conjugate acid? Which is the conjugate base? Well, the conjugate acid, let's pick a different color here. I'm feeling green. This conjugate acid turns into the conjugate base, and I'm going to pick blue for my base. This base becomes the conjugate acid. So acids become the conjugate base, bases become the conjugate acid. I'm laughing because I know that this can sound confusing, but I hope this makes sense to everybody. So before we finish today, how are you guys doing? It's 5:03. I'm going to go a little bit further, but I want to make sure everybody is comfortable with this. So I have a message from Mohammed. Yeah, okay, I'm sorry, I'm just reading the message. So yeah, normally, after determining your acid and base in the reactant side, the products will be the conjugate base and conjugate acid. Yes, absolutely. So, step number 1 is to confirm or identify the acid and base on the left, the reactants, and then choose the opposite for the products. Yeah, that's a really good way to think about it. And I know, this is a strange topic, but it is actually important for later because I don't know if you guys noticed, but every one of these equations has an equilibrium. And we're going to get back into equilibrium in this chapter. So, I didn't know this question was here. Okay, so it's 5:05. It's 5 minutes after 5. I'm going to give you a couple of minutes to try these questions. The answers are there as you saw. Oh, I really wanted to get further today, but anyways, that's okay. So I'm going to give you guys 5 minutes to try these questions, and then we will check your answers. And I think that might be it for today. So question number 1 asks, what are the conjugate bases of these acids? And question number 2 asks, what are the conjugate acids of these bases? These are kind of tricky questions. You kind of got to really think about this. So I'm going to give you guys a minute or two to do this, and then I'll check the answer. And if you guys are following with me in the chat, Abdullahim gives a really good hint. For acids, you just take a hydrogen atom off, and for bases, you add a hydrogen atom. I could not say that better myself. So thank you, Abdullahim. If anybody is confused, just read that message in the chat. That is the literal perfect answer. So I'll be back in let's say 2 minutes, and I'll check your answers. Okay, so let's look at the answers. I forgot to hit record the last time. So think about this question. Conjugate bases of these acids. Acids are chemicals that donate. Let me pick a different color here. Let's choose red. I'm going to go back to red. So chemicals or acids are chemicals that donate their protons. So the idea here is that these chemicals would lose their proton. Now, this is really important, and Aman in the chat brought up something very important. Do the signs matter? And this is something you need to remember from Chemistry 1120. Yes, the signs matter. And if you had me for 1120, maybe I was a bit easy on you. But for acids and bases, the signs definitely matter. So the idea is, if this hydrogen disappears, or sorry, I shouldn't say disappear, but gets donated, the bromine then becomes minus. You can write aqueous. I don't care about the aqueous, so don't worry about that. I'm more concerned about the sign of the chemical. If HBr is a stable neutral compound and it loses a hydrogen, it becomes negative. Same thing here. If H2SO4 loses one hydrogen, it will become negative. And you can kind of see a pattern here. And the pattern is slightly disrupted in question C, because if H2PO4 minus loses a proton, it becomes H1, but I don't need to write the 1, PO3 2 minus. Really pay attention to that. Why is it 2 minus? I removed a proton, so it becomes more negative. In question 2, it asks, what are the conjugate acids of these bases? So that means they are going to gain a proton. So this is pretty easy. I get HI. Notice there's no charge on this compound. H positive, I negative, neutral. NH3 becomes NH4. That makes sense, but it's NH4 positive. It's gaining a positive charge. It's gaining a proton. And then finally, I would get H2ASO4 minus, not 2 minus. Again, I'm looking after my charge. So how do you guys feel about that? I have a question in the chat. How can we make difference between 2 minus? Ooh, I'm not sure I understand this question. It says, how can we make difference between 2 minus as it loses hydrogen or 2 minus as it gains 2 electrons? I unfortunately don't know how to answer that question. Yeah, I'm sure, I mean, I know it's a good question. I just don't know what you mean. So don't leave yet. I'm gonna answer this question no matter what, and we'll see what happens. Yeah. Okay. So yeah, Cl minus, it needs 1 electron, but it also loses H. I think Iman, you're thinking too much into this. I think you're trying to connect ions, or sorry, cations and anions from 1120. Like Cl minus cannot lose a hydrogen because it does not have a hydrogen, right? So Cl minus cannot be an acid because it does not have a hydrogen. I hope that makes sense. So again, what you're saying is, Cl minus, it does not have a hydrogen. It cannot be an acid. It has to be a base. I'm getting more questions in the chat, which I will read now. From Yasmin. Can you explain number 1, letter C? Yes, absolutely. Okay, so the question in the chat is, well, what's up? Or can I explain question number 1, letter C? Why does it become 2 minus? Okay, that's a really good question. So let me clear my notes here. Oops, I didn't mean to do that. Sorry. I honestly thought I was going to get like this section done today, but anyway, that's fine. I'm laughing because we didn't get what I wanted to do done, but I'm very, very happy about these questions. Okay, so Yasmin's question C. What's going on with this guy? Why does H2PO3 minus become HPO3 2 minus? Okay, so first step, remember, H plus, and again, that plus is what we are dealing with. It's H positive. It's a proton. Take this chemical and remove a proton. So I'm going to remove a hydrogen. So H, again, I'm not worrying about charges. I'm not worrying about anything like that. I'm just removing a proton. So H2 becomes H1PO3. Okay, that's fine. Now, the charge initially on this compound was negative, but I removed a positive chemical. I removed a proton. I removed 1 plus. So again, you can kind of think of this like, oh, I hate to do this, but I have to. You can kind of think of like a number line in math. Oops, I don't know what I'm doing. So this chemical is at -1. But when I remove a proton, it loses a charge and goes down to -2. So if you're wondering where the -2 comes from, it's because I lose a positive charge, it becomes more negative, and it becomes -2. And thank you, Abdullahim. You like honestly, and I could say this totally with honesty. I wish I could see you guys in the classroom. Iman knows this. I've said this before. You guys, like honestly, you guys are one of my favorite classes. I have so much fun with you. I mean that so much. So thank you guys so much. And thank you, Aman. Thank you, Yasmin and Abdullahim and Mohammed and everybody. Like I honestly, you guys are one of honestly my best classes. I really wish we could meet in person. Maybe after the COVID virus ends, we can get together. Iman asks if I'm teaching chemistry 3. That's I developed that course. That's my course. I hope, inshallah, that I am teaching chemistry 3. So I hope I see you all again in that course. And thank you, Harold. Have a nice evening. And yes, thank you. I will have a nice dinner. I'm probably going to do Talabat tonight, I think. So yeah, thanks everybody. We didn't get as far as I wanted today, but that's totally fine. Thank you. Thanks, Abdullah. Thanks, everybody. Take care. Wear a mask. Be safe. Yes, be safe. Goodbye.
Have a good day, Mr.
Yes, you too. Have a great day. Be safe.